Hello, welcome to this video. The topic here is adsorption, absorption, sorption and points related to that. Let us first see the definition for adsorption. By definition, adsorption is a process wherein the surface of solids attract and retain molecules of the medium in which they are kept. Let us take an example. This is powdered charcoal and it is kept in a medium containing ammonia. I have used another color here only to differentiate the boundary of charcoal and the presence of ammonia. Now, after keeping this for some time in this medium, if the powdered charcoal piece is taken out, we find that the ammonia sticks to the surface or the interface of the powdered charcoal. Now, ammonia is not of this color. I have only used this color to show you where exactly ammonia is expected to be present. This process is adsorption of ammonia on the surface of the piece of charcoal. Now, a few terms need to be learned here. Powdered charcoal is called adsorbent. Powdered charcoal is called adsorbent, and this is adsorbate. Okay. Ammonia is adsorbate. And powdered charcoal is adsorbent. I have marked it here. There are a large number of examples for adsorbents. Powdered charcoal can adsorb many gases, say for example oxygen, nitrogen, ammonia we have already shown, then sulfur dioxide and the like. Such substances can be adsorbed by powdered charcoal, whereas animal charcoal, when this is added to a solution containing methylene blue, it gets decolorized. The particles responsible for the blue color is adsorbed on the animal charcoal pieces and the solution turns colorless. Similarly, animal charcoal is used in another very common life situation, that is manufacture of sugar. When sugar is manufactured, the first solution that is got, the raw sugar solution that is obtained, will be colored. But the sugar that is available in the market, as you know, is white in color, glistening white in color. So, for decolorizing that, animal charcoal is used. That solution is passed over animal charcoal and it becomes white in color. There is another thing called silica gel which can adsorb water from the atmosphere. The atmosphere becomes dry in the presence of silica gel. This also is a case of adsorption. There are ever so many other substances also which function as adsorbents in other situations. For example, colloids, alumina gel, clay, etc. have this capacity to adsorb certain adsorbates. This process adsorption is a surface phenomenon. It is a surface phenomenon, as you have seen here. It sticks only to the surface. This is different from absorption. Let us see an example. A piece of cotton is kept in colored ink. After some time, it is seen that the whole cotton piece takes the color of this ink. Particles have really penetrated into the bulk of this cotton. Whereas in this case, it is only a surface phenomenon. Ammonia could enter only into the surface, that is interface. It has some thickness, a few layer thick it is. We have already seen that in the previous video. So it is different. These two processes are different. There are a few other points also you can note down as differences between adsorption and absorption. Let us list them. Adsorption, I have made a column here. Adsorption and absorption. Substance penetrates into only the surface, whereas here it penetrates the bulk also. It penetrates the bulk also in absorption. Now the substance concentrates only on the surface. The substance concentrates uniformly throughout in the case of absorption. Now let us talk about rate of adsorption. In the beginning, rate of adsorption will be very high. Now as time proceeds, the rate of adsorption decreases and it falls. It becomes very low. After a certain stage, an equilibrium point is reached. We will talk about that in the next video. But here what happens in the case of absorption, the rate is same throughout. So a small question may be asked from here. What are the differences between adsorption and absorption? It's a very simple question. That is, by the end of this video, you should be able to differentiate adsorption and absorption. So here be very careful. This is adsorption, this is absorption. Now let us see another point. What is that? Desorption. The adsorbed substance can be removed from the surface of the adsorbent by suitable methods. That process is called desorption. What is sorption? Sorption. It is a process wherein both adsorption and absorption take place simultaneously. So in this case, adsorption and absorption take place together simultaneously. Adsorption and absorption take place simultaneously. We can cite an example when powdered charcoal kept in contact with water. Charcoal kept in contact with water. Over this, ammonia is passed. Ammonia is passed over this substance. Charcoal is in contact with water. It is also in contact with ammonia. What happens here? Charcoal adsorbs ammonia but absorbs water. So this is the difference. In this case, this is a case of sorption. Now you would have heard about anhydrous calcium chloride. Anhydrous calcium chloride. Anhydrous calcium chloride. Anhydrous calcium chloride has the capacity to absorb water from the atmosphere, whereas silica gel adsorbs water. Silica gel adsorbs water. Anhydrous calcium chloride absorbs water. So both can remove water, but the process by which silica gel removes water is by adsorption, and how calcium chloride does this is by absorption. So this is all in this video. The next topic, mechanism of adsorption, we will see in the next video.